Hi everyone, welcome back for another week of content in statistics. In this section we're going to be looking at shading and naming regions of Venn diagrams. I hope everyone has found these videos helpful and that the content we're covering is making sense. I've been sending some private comments to everyone just as a way of touching base individually on the work you have. And most of the time, if there's something I'm noticing, I'm just touching on it and making sure that we're both in agreement of what the misconception or confusion may be, rather than asking you to redo the whole assignment. So where we left off was identifying different values and placing them, or identifying where certain values fall in Venn diagrams. What we're looking at today is more of a broad generalization of where certain regions of Venn diagrams fall, or what the names of certain regions of Venn diagrams are. So getting into things, we have two definitions and notations we need to clarify before we actually start doing this. The first is called set union. Sometimes when we talk about union, we're talking about actually the word or. So if I'm saying like set A or B, it could be me saying something like I'm having spaghetti or lasagna for dinner. In that case, either spaghetti is good or lasagna is good. The or in math means one or the other will satisfy a requirement. So when we talk about union, there's two ways we're going to approach this. The first is with notation. So if we have two sets, let's call them A and B, we would show set union A union B like so. This one's really straightforward because the U stands for union. It's easy to remember, and that's exactly how I remember it. So A union B is considering sets A, B, and the overlap of those two. So we're considering all of A as well as all of B and what they share in common. So if we just draw a quick visual of this, we'll clean this up for those of you who are particular. There we go. So let's consider a set. Let's call it A. Here's set A. Let's consider a second set. Let's call it B. Here's set B. And what we're going to do is show the union of these. So if we want the union of it, I consider all of set A. So there's set A shaded. And then at the same time, I consider all of set B, as well as the overlap in these. So A union B is all of set A as well as all of set B and their overlap. So we have a notation and we have a visual of this. So that is set union. The second type we can have is set intersection. So A intersect B is how we talk about this. So if we have two sets again, let's call them A and B once again. So A, B. The way we notate intersection is actually an upside down U. And intersection actually is another way we can refer to as and. So when I say I'm having cake and pie for dessert, I'd expect to have both of those. I want both of those to make that statement true. If I say and, I'm considering the first and the second of whatever that proposition is, whatever I'm connecting with it. So here's set A and B. One way you can remember this is you can put an A there. I don't like the little gimmicks. I just remember it as being the opposite of union. If union is U, intersection is the upside down. So again, if we show a visual of this, oh, that's much better. Look at me learning on this. My circles still need some help. Here's A. Here's B. If we want to show the intersection of two, I'm going to consider set A. So here's set A. And let's shade all of it. So we take set A. Then we consider a different set. Let's call this B. So we shade set B. And the intersection is both A and B. It's where the two overlap. So this is that joint, the overlap of the two sets. So if we draw or show set intersection, it's this region right here. So one way we can think about it is A and B. It's what they share. It's where they overlap. Union, on the other hand, would be A or B. Those words sometimes can help in the connectiveness of this. So where we're headed now is we're going to do two things. The first thing we're going to do is shade regions of Venn diagrams. And there's a structure, there's a process we can follow in this. Eventually you'll get to a point where it just kind of clicks and you look at it and you're like, oh yeah, you work through it mentally and you can get there. But for now, we'll slowly build on it. And then the second thing we're going to do is name shaded regions of Venn diagrams. I had to make sure I was recording there for a second. So if I want to shade A, we're starting really basic again. I know a lot of you can just look at this probably. So we want to shade set A. Well, we just consider A. There it is. And we want all of this set. So if we want to shade A, I'm doing what this tablet is actually used for. There's set A. And I don't know if I'm going to get it perfect. If I pick up the pen, it does weird things and double shades. So we shaded A, and we're done. We're good to go. Next, we want to shade B, complement. So as a reminder, we consider set B, and the complement is everything that is not in front of this apostrophe or this complement symbol. So if I want to shade B complement, well, I think to myself, well, where's B? Well, here's set B. I'm going to outline it this time. Here's set B. Oh my. And if we want everything that's not B, basically, this can also be notated as not B. I want to shade everything outside of that region. And I'm just going to quickly go through this. This tablet's rather small. I'm making excuses, but I think I can at this point. So we shade all of this region. So B complement would be everything that's not set B. That's another way we can think about complement. And there we have it. Let's get into a little more interesting. We want to shade A union B. So whenever I think or see union, I consider take A and combine it with B. So we want to consider all of set A. So right here is all of set A. And when we union two sets, we take all of A as well as all of B. Now we never double list elements in sets, so that's why we don't double shade in this. Like I'm just going to consider this as being B considered as well. Or I'm going to take this and combine B. A combine with B. A or B. As well as the overlap. Because if I'm having spaghetti or lasagna and I end up having both for dinner, that's not a bad thing either. So A union B. Again, these are pretty straightforward and will get more tedious and challenging as we go. A intersect B, again, we just want to consider the overlap of the two sets. Oh, I'm jumping ahead right now. We would want to double shade this. So I'm going to shade all of A as well as all of B, and since we've seen this already, I will just skip ahead actually. So there's the intersection of those two sets. All right. So A intersect B and then the complement of it. So I want to consider where A intersect B is and shade everything that's not that. So the complement of A intersect B, well again if I outline A intersect B, which we just looked at, if this is A intersect B outlined, I want to shade everything outside of this. So it's everything that A and B do not share. So there we have it. All right. So now when we build into this, we want to name shaded regions. So this is where we can start to take a few directions, but there is an approach we can kind of outline here. Sometimes you can just commit it to memory. What I like to think about is in words that don't really require the sophistication of sets what's shaded, and I see everything that's not B shaded. So we've seen this, we know this is B complement already. All right, so name the shaded region. So what this looks like we have going on is we have set A shaded, but we're taking B out. So a general rule here is whenever we take something out of a set, so I'm missing part of a set, we're going to be intersecting with something else. So if I consider what's going on here, I have A shaded. I know A is shaded, so I'm going to say A. Whenever we're naming sets, we only list each set once. So I don't say like A union B intersect A. We just name each set that we're interested in once. So what we have here is we have set A. So if I shade set A in another color, let's do this darker. I'm going to shade set A right here. Shade set A. I'm tripping up on my words. So here's set A shaded. But it looks like what's going on is we're taking B out of it. So how do we end up taking B out of it? Well, if I want to take B out of something, I want to consider the complement of B. So there's something going on here with B complement. Are we intersecting B complement or are we union B complement? Well, if it was union B complement, we would have B complement included. We wouldn't have anything not shaded outside of B. So this must be actually intersecting B complement. And to show you that, let's choose another color. Let's go to green. To show you what's going on here is I have this grayish and it's red in this case. I have B complement actually considered. But what's going on here is if I start shading B complement, you see that the region we're interested in is where the double overlap is. So whenever we have a double overlap, and that's all we're considering, we're intersecting. So that's a general rule. Or whenever something's taken out of a set, we're intersecting as well. So this shows a lot more clearly that if I consider A, well, A is all of the gray region, but we don't want this wedge of it. It's where the double overlap is happening, where the double shading, so we intersect B complement. Let's move on to another one. So in this case, there's nothing taken out of A, nothing taken out of B, so we must be unioning, and we've seen this already. This is A union B. So I just really quickly think to myself, well, is there something taken out of a set? If it is, there's intersection. Are there multiple sets combined? If there is, then it's probably going to be a union. Alright, so naming this shaded region. Again, if we think about this, I have B and I'm taking some part out of it. So it's going to have to deal with A and B. If I'm taking a part out of it, I'm going to be intersecting. But I want most of B. I have A taken out. So similarly, we have A complement, which is everything that's not A. I started shading A there. But we're looking at where that overlaps B. So if I just draw this really quick, if I think about this, here's A. I want everything outside of it. Everything outside of A is shaded. Then it doesn't really matter if I bring a B in. So if I bring B in here, here's B. Well, I want B, but the part I want of B is where the black and red is shaded. So I think about intersection to get an overlap, to get where two shaded regions occur. Okay. So that rule that we were saying where something's taken out with intersection most of the time will hold. So let's test it here. It looks like we don't have all of A, we don't have all of B. There's some part taken out, so we must be intersecting. So what's going on here is if I think about in words what's shaded, I have everything shaded in A, everything shaded in B except for their intersection or their overlap. So if I want everything except for the overlap, well, if I think A intersect B, that is this region right here. I don't want that region, so I complement it to exclude that region. So A intersect B complement is what we have going on there. Finally, last bit. Again, this is practice, so you need to be patient with this. It's going to take some time, and if we were meeting in class, we'd rapid fire through a lot of these. So we're going to spend some time working on this. Then as you've seen the assignment this week, the second half isn't working on this again. We'll probably come back to it the following Monday, just because we have the luxury of taking some time here. So what we have we have three sets. We have A, we have B, and we also have C. So we only want to list each letter once, so we want to think about what's going on here. Well, if I think about in words, I have all of A, all of B, and all of C. So I'm taking set A, combining it with B, combining it with C, and if we want to combine sets, we union those sets. So this would be A union B union C. Sometimes we put parentheses around and say, well, this is A union B. And then at the same time, I can union that with C. This would be like a set in itself, or we can just go through and do it this way. The notation isn't super important in this case because we're just combining sets. So you've made it through the video. Look ahead for some practice. Again, we're going to build up on this. Be patient with the process. I may send some private comments asking you to go through and revamp or adjust something. I hope the video helped. Let me know what questions you have. Make sure you fill out the little reflection in the Google Doc that's posted as the actual assignment for this.